Hello everyone, and welcome to 7th grade Math Module 6, Geometry. In this video, we're looking at Lesson 3, Solving for Unknown Angles Using Equations. Our learning goal is to make sure we can analyze and write equations to calculate unknown angles in word problems and in diagrams. This will help us to master Standard 7 GB5, use facts about supplementary, complementary, vertical, and adjacent angles in a multi-step problem to write and solve simple equations for an unknown angle in a figure. This is going to be a bit of a review of topics we already covered back in Module 3. There's two pieces that we covered then that we will be using today. The first is how to solve any 7th grade algebra problem. Remember, you can do the distributive property first, then combine any like terms, and then undo your multiplication or addition or subtraction with the inverse, and then multiplication or division with the inverse. Once you've done that, your variables should be isolated and you can just check your answer. The other thing that we'll be using are angle relationships from Module 3. So we talked about adjacent angles that have a common ray and add to their larger angle outside of them. We have vertical angles, which are on that opposite side of intersecting lines. We look for that X shape, and those are equal. We have supplementary angles, which are two adjacent angles whose outside rays form a straight line, which is 180 degrees. And then we have complementary angles as well, which add up to 90. Those are a type of adjacent. Then we have angles on a point, which add up to 360 degrees. And that only works if we have all of the angles around that point that we either have a variable or a number for to put into our equation. If any are missing, we can't use them. So our goal today is just to use that information about our angles to write equations and then using our steps to solve those equations algebraically. Four rays meet at a common endpoint. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve an equation to find the value of x, find the measurements of angles BAC and angle DAE. So the hardest part of this is always just figuring out what your angle relationships are. Then when you do that, all you need to do is use those relationships to write up that equation. So in this, I find it easy sometimes to highlight my different angles so I can get a sense of what relationships I'm looking at. And here I have either a number or a variable or some other term for every single angle here. I don't have any x's for vertical angles, don't seem to have any pairs of rays that make a straight line for angles on a line. I do have a 90-degree angle, but there's no angles inside of it to add up to that 90. So it looks like I'm looking at angles on a point here. And since these angles are all on a point, they're going to add up to 360. So in order to write my equation, I just take the values of each of my angles and I add them up and set them equal to 360. So when I wrote mine, I color-coded, so I kept track of where I got my angles from and to make sure that I got every single one of my angles represented here. So now I need to follow my steps for solving algebra problems. No parentheses that require distributing in this problem. So then what I have to do next is combine like terms. I went ahead and highlighted underneath of my terms for my terms that were alike. So my x and my 5x share a common variable, and 90 and 204 are both constants. They're just regular numbers, so they can combine as well. So when I combine those terms, x plus 5x is 6x, and then 90 plus 204 gives me 294. So now I'm left with a two-step equation. So I do my reverse PEMDAS and undo my addition. The inverse of adding 294 would be subtracting 294. And when I do that and they cancel out, it leaves me with 6x is equal to 66. Then, to undo my multiplication, I do the inverse, which is division by 6 on both sides. Canceling out, leaving me with x is equal to 11 degrees when I do that 66 divided by 6. Now I can't just stop here. I had to find the measurements of angles BAC and angle DAE. So first I want to look at what expressions I had inside those angles to begin with. And angle BAC just had the variable x, so I know that BAC is what x equals, which is 11. For angle DAE, we had 5x in there, so in order to find out the value of angle DAE, I would have to do 5 times my value for x, which gets us 55 degrees for angle DAE. Two lines meet at a point that is also the endpoint of two rays. In a complete sentence, describe the relevant angle relationships in the diagram. Set up and solve an equation to find the value of x. Find the measurement of angle BAC and angle BAH. So you can pause the video here and you can try to find an angle relationship and then write and solve an equation for the values of those two angles. So looking at what we have here, we don't have all of our angles on a point. So we can't use that angle relationship. We have two that we just don't know anything about, and that we could find out what they are, and if you do, then you could use that. But in the meanwhile, we don't have that information, so that's not the first one I would go for. We do have some angles on a line, but not with what exactly we're looking for. There are ways that you could use angles on a line to get your answer, but again, it's not the first one that I see. What I'm noticing right here is that I've got opposite sides of these two intersecting lines. I know the angles inside, and there's two inside of each, but all together we've got those two opposite sides. So we've got some vertical angles here that each contain two angles, and those adjacent angles would just add up to be that larger angle. So I can set up my orange and green angle here to be equal to my purple and yellow one. So again, you could have used some of those other relationships. It would take you a bit more steps, but this is the first angle relationship that I noticed. So I'm going to set up my angle equation this way. If you set yours up differently, please don't change it. Let's check and see if you get the same thing that I do with your relationship. So now that I'm here, I just need to solve this using my algebra steps. So I'm going to combine my like terms. My regular 90 and 30 give me 120, and my 8x and my 3x leave me with 8x. Or sorry, 5x and 3x give me 8x. Next, I'm going to undo, there's no addition or subtraction undo, so it's just undo my multiplication with division. And I get that my x equals 15 degrees. So if you had used another strategy of maybe finding what those other angles that I don't have highlighted were, and then going around, you could have eventually gotten to that answer as well. So now to find the measures of my angles, all I need to do is replace in the terms for each angle. So BAC was 5x, so 5 times our 15 gets us 75 degrees for that angle. And then BAH is 3x, and when we sub that in, we get 45 degrees for that angle. What does this make you wonder about solving problems with angles? Write your questions down so you don't forget them. Then you can try to find answers online or ask a classmate or teacher. Thanks for watching, and when you're trying this on your own, remember, if you learned from your failures, then you succeeded.